Hi all, welcome to part 31 module 2 computer networks. So we were discussing the classic ethernet in detail with that CSMA bar CD exponential backoff algorithm, everything we saw in the last video lecture. Now we move on to some other category of ethernet. So far classic ethernet it's a bus based topology, right? So every device is being connected into into a single shared bus. So now that topology we are changing to hub, right? So to a central shared device called hub. The sharing, all those concepts were similar only, but instead of bus topology we are depending on a star kind of a topology. And who is sitting on this center of the star topology? And that special shared device called a hub. So that is a basic idea. So when we are changing the topology, so in typical ethernet, what are all the benefits we are getting and what are all the cons? So the problems associated with finding breaks or loose connections of single long cable architecture of ethernet draw it toward a different kind of wiring pattern in which each station has a dedicated cable running to a central hub. So that is the thing. So if you look at the normal classic ethernet based on the bus topology, you can see, so this is a typical problem that we are facing. If there is any cable break, how we can find it, where that break actually happened, because as a failure at some point of that single shared bus can disturb the entire system, and similarly loose connections, all are the things. So first of all, if anything like that is happening, it is going to affect the entire system. And what about the troubleshooting part? So to tackle this, people started thinking a different topology for it. So that is a hub based topology, where all devices are being connected to a central hub, looking like a star topology. Yeah. So what is a hub? Hub is simply connects all the attached wires electrically as they have soldered together. So we will get the feel like everything is soldered together. So in that way the hub will act as a central shared point. So the wires were telephone company twisted pairs, of course. Using twisted pairs, the connections will be made from the device to the hub. Since most of the office buildings were already wired using this, so this way, and normally plenty of spares were available, so it was easy for them to shift to this kind of a topology at the initial phase. So this reuse was a win, but what's the problem there? But it did reduce the maximum cable length from the hub to the device to be some 100 meters. So a device to hub maximum 100 meters is supported, because just normal twisted pairs only. So after that the signal will start attenuating. So in that way, so everything should be connected in a close proximity. And of course, if you are using category 5 twisted pair, you can go up to 200 meters. So that is the kind of limitation we are having. But you hope you remember, in West topology also we are having the same limitation, particularly if you use coaxial cable and all, we may be getting some 500 meters of maximum cable length. But after that we were using the repeaters, and we can extend that length with some restrictions and all. But here it is something different, as everybody is being connected to the central hub. The maximum distance from the device to the hub is restricted to 100 meters. So adding or removing a station is similar here, and cable breaks can easily be detected, because if somebody is facing some problem, you just have to check the connection from that device to the central hub, and not throughout that media. Right. So adding as well as removing of the station is easy, and easy for us to detect the cable breaks. Yes. Okay. So with the advantage of being able to use the existing wiring, and the ease of maintenance, the twisted pair hubs based topology quickly become the dominant form of Ethernet. So just after the classic Ethernet. So however, the hubs do not increase the capacity, that you have to keep in mind. So we may feel like many devices are being connected to the hub, so it can increase the capacity. It is not like that. So just like the bus, this is also shared resource only. So because they are logically equivalent, so that is very important. So even though you just change the topology, the working, the capacity handling, everything is logically equivalent to the classic Ethernet, the base based single cable based classic Ethernet only. We couldn't achieve something more. As more and more stations are added, definitely each station gets decreasing share of the fixed capacity. So the hub, the shared resource, it is having a fixed capacity, so everybody can share it. But when we keep on adding more devices, definitely the amount of share per device will be less. The same problem we are facing with the bus topology. So eventually the LAN will saturate as you add more and more device. So you can see, so this is the idea. This left side we have the hub based architecture, where this is the central shared hub. To this way many devices are being connected, and the point at which the device is connected to the central hub is what we call as the port. Okay, so these are all the cable, maybe to pair wires, and at the end of these wires the devices were connected, and this maximum length is restricted to be some 100 meter, like that. So but you know, the communication is something happening inside the hub. There is no there is nothing intelligence added inside the hub. Simply everybody is coming over this hub inside part, and it will, so for example here A want to communicate with B, so it is just coming over this point and it will be moved towards B. Suppose at the same time device C also want to communicate with the device D, right? So A is communicating with the B, C, and C is trying to communicate with the D. So what will happen? So this is the communication of A, right? A and B, and this is the communication of C and D. So now if both of them are trying at the same time, definitely inside the hub the collision will happen. So for tackling this collision, you have to depend on the CSMA bar CD protocol. So it just we just change the topology only, but the working everything is just like the classic Ethernet only, right? The best topology. You still have to depend on the CSMA bar CD protocol. But if you look at the switch based protocol, it is something interesting, right? So this is what we are going to see next, the switch based architecture, where so just like the shared common hub, that device now we call it as the switch. Okay, so what makes switch different from hub? So it is very clear from the picture that as usual we were connecting the devices to this port only, say A and B, and this is device C and D, right? Everybody will be connected to the port. Now inside the port there is something intelligence we added, like the ports were connected in a mesh based topology, something like this. Inside this kind of a strong dedicated connection is there between the ports. So what will happen if A want to communicate with B? So A will it will take the data like this, so it will switch. So this is something what you can call as switching, right? So from this port it will it will be switched to this path. It can choose any path like this. For example, it is, for the time being, it is taking a path like this, and finally say it is moving to B. And if C and D are coming, it can be given a different path. So that is the idea, right? Say it can come over like this and it can use this. Now both are happening simultaneously at the same time without the communication between A and B is not going to affect the communication between C and D. And how this switching and all happening, it's something when we move on to this switching technology in detail, you will understand that. So this is something a very simple way I shown you, but you can do it in a more intelligent way, so that many communication is possible parallelly at the same time without disturbing the other. So this is what makes switch based Ethernet a very powerful one. So it is just a breakthrough, right? Just after that classic Ethernet, in between people tried with hub, but when they changed that hub into a more intelligent device, a switch, they got a tremendous better performance, right? So that is what we are going to see. So hope the idea is clear. So that is what we call as a switched Ethernet, right? So let me clear the marks. Yeah. So the switched Ethernet provides another way to deal with increased load. So they can handle increased load without any worrying on collision kind of thing. So the heart of the system is a switch. So instead of hub, now we have the data link device called a switch, containing a high speed backbone that connects all of the ports. So this high speed backbone network, the mesh based network like what we already seen, is what make this switched Ethernet a robust one. So from the outside switch looks like a hub only. So they are both boxes typically with 4 to 48 ports. So normally you could see in your networking lab and all, you can observe these switches and you can see how many ports were there. Typically this 48 is something that we are seeing, and we can have a range from 4 to 48 ports for a particular switch, and that many devices can be connected, and each with a standard RJ45 connector. So this is a connector used for connecting the device to the port for the twisted pair cable, right? Particularly if you are using twisted pair cable, just like the hub based Ethernet. So each cable connects the switch or hub to a single computer. Now a switch has the same advantage as a hub too. It is easy to add or remove a new station by plugging and unplugging, of course, and it is easy to find the most fault since the flaky cables of the ports will usually affect just one station. So the breaking of the cable and related issues you can troubleshoot easily, and at the same time the adding and removal of the devices were easy, right? So that advantage still maintained, and there is still a shared component. So of course we have this kind of vulnerability just like hub. Switch is also a shared component, so if the switch as a whole is failed, the entire system will fail. But if all stations lose connectivity, definitely it is a problem with the switch, right? So the IT folks know that what to do to fix the problem. Simply replace the switch, right? So you can simply replace the switch if you found that it's a problem with the switch. Definitely if it is a problem with the switch, everybody is going to be affected. In that time you can replace the switch and with a better one. Right, so in that way you can simply solve the problem, so you don't have to worry about the failure of the single switch, right? Switch Ethernet. So inside the switch, however, something very different is happening, like what we already seen. The switches only output frames to the ports for which those frames are destined. Right, some the correct port identification is happening, right? Like what I shown you already from A to B. Inside that switching will happen properly and correctly. It will be delivered to the outgoing port in such a way that it can hand over to B. So in that way, so when a switch port receives an Ethernet frame from a station, say like what we already seen, say from A, the switch checks the Ethernet address to see which port the frame is destined for. So the destination is B in that example, right? So it will check it, and this step requires the switch to be able to work with which ports corresponds to which address. Now there should be some kind of mapping table inside the switch, and that will tell you so this particular destination address, it is better for you to deliver to this port. So this port, if you deliver the frame, it can help you to reach the destination properly. So that kind of a intelligence switch is already having. Intelligence in the sense some kind of table will be used by the switch, so that you have to configure. So the switch then forwards the frame over the high speed backbone to the destination port correctly without making any collision with others. The backplane typically runs at many gigabits per second speed using the proprietary protocol that does not need to be standardized because it is entirely hidden inside the switch. So the protocol that is to be used inside the switch for identifying the port corresponding to the destination address and for the switching purpose, everything is typically a proprietary protocol that is proprietary to that particular switch. Why it is so? We don't have to standardize it because it is something that runs locally inside the switch only, right? So you can depend on the proprietary software. It is not going to affect the outside world, right? So the destination port then transmits the frame on the wire so that it reaches the intended station. So none of the other ports even knows that some communication is happening inside. Say from A to B, the communication is happening smoothly without affecting the communication between C and D, right? Yeah, so what happens if more than one of the station or the ports wants to send a frame at the same time? Simply again switch differ from hub. So in hub all stations are in the same collision domain. So this is something you can keep in your mind. So it's a terminology. Same collision domain means everybody is getting a common shared hub. So when two people try to communicate at the same time, definitely it will be collided inside the hub because everybody is in a single collision domain. But when it comes to switch, before that, as it is sharing a single collision domain, chances of collision is very high. So how it will handle handle collision by running the CSMA bar CD algorithm to schedule their transmission. But when it comes to switch, each port has its own independent collision domain. So for A is connected to this port, and inside this through some path it is coming here, and this port is having, if only one device is connected to this port, you don't have to worry much, right? Similarly, this only device. So as soon as you are connecting only one device per port, you don't have to worry about the collision at all. So the different collision domain per port is available. So like that you can view, that means if there are 48 ports in a typical switch, it is possible to have 48 different collision domain, or that many communication. If it is, you are treating it as pairwise, some 24 pairs of communication can happen without can happen simultaneously without affecting the other rest of the communication. So you don't have to worry about the collision at all, because the collision domain, from a single collision domain, now we are dividing it into the number of collision domain that is proportional to number of ports inside the switch. So in the common base, that cable is full duplex. If it is full duplex, then both the station and the port can send a frame on the cable at the same time without worrying about this. So full duplex communication, you know, from A to B as well as from B to A, separate connection will be there. So it will happen nicely without any worry on collision at all. But when it comes to half duplex communication, if to and fro communication is happening at the same time, that same port will be reused, and that time collision chances were there. So the collision are now impossible, and CSMA bar CD is not needed at all when it comes to full duplex switching, switch based communication. However, if the cable is half duplex, the station and the port must contend for the transmission with the CSMA bar CD used in the usual way. So half duplex based switching technology, as the to and fro communication depending on the same port, collision chances were there, and that time you can tackle it with the CSMA bar CD. But definitely for full duplex switching based technology, you don't have to worry about the collision at all, right? So it is something like this. The device is being connected to a particular port, something like this, and many other. So all these are twisted pairs. So right, this white colors means unused ports, and others are engaged. And from a particular port, you can have a connection to a different hub. So here switch and hub works together, right? In that way also you can configure depending on the need. So switched Ethernet performance gain, so in what way it outperforms the typical classical Ethernet based one. A switch improves the performance over a hub in two ways. First, there are no collisions at all, right? Like what we already seen. So the capacity is used more efficiently. No collision in the sense when it comes to full duplex based switching technology. Okay, so we can have efficient utilization of the capacity. And second benefit is, and more important one is, switch multiple frames can be sent simultaneously by different station without bothering about others. That also we see. So these frames will reach the switch ports and travel over the switch backbone to the output on the proper ports correctly. So however, so that's how that switching is happening inside that switch device. So that is a different topic. Okay, so that I didn't touch anyway. However, since two frames might be sent on the same output port at the same time, the switch must be having. So that you can think of, like in that previous example, what I was trying to explain you is, this A is trying to communicate with the B. So once the communication reaches inside the switch, it is doing something, and finally correctly it is delivered to B. Now C, suppose, also want to communicate with the B. Then there is a chance that from A it is coming to B, from C also it is coming to B. So at this point the collision possibilities are there. Now how it is handling without collision is by means of buffering. So this is something you can add as an additional add-on. At every output port you can keep some buffer, and if the frame is coming from both A and C at the same time, the one who is coming late will be kept in the buffer, and we will not let it move on to the port, and will make it some collision. So that we will avoid by means of buffering. So overall, these improvements give a large performance win that is not possible with the hub, of course. The total system throughput can be increased by an order of magnitude depending on the number of ports and the traffic patterns we are having. So another benefit is from the security point of view, because most of the LAN interfaces have something called a promiscuous mode, right? So promiscuous mode means what? In which all frames are given to each computer and not just to, the one which is addressed to it. This is something I already told you, whether it is in classic Ethernet or in hub-based Ethernet, inside the local area network or inside that hub or inside that cable, broadcasting is happening, so that every communication is being read by everyone else, right? And only those so every device is having some responsibility, like they will take their own MAC address and they will check it against the MAC address, destination MAC address that is present in the frame. So if there is a match, they will understand that it is for me and they will take it. If it is not matched, they will simply ignore. But if they are not ignoring, right? So like that you can think. That means every communication is means every device which are connected as part of the hub-based Ethernet or classic Ethernet were exposed to all communications. So that is what we call as a promiscuous mode. So a device is in promiscuous mode, it can see the communication that is happening in the entire Ethernet. So sometimes for some packet sniffing kind of application, for analyzing the packets, the type of communication, some kind of traffic monitoring, you can forcefully make some of the devices as under promiscuous mode. But in general, for security aspects, you can make some of the devices in promiscuous mode. But otherwise, if you are giving such a permission to everyone to access everyone else's data, that is not going to be a good method. So we have some security vulnerability with the classic Ethernet as well as with the hub-based Ethernet. But that kind of a problem is not there with the switch-based Ethernet, because now something we already seen from A to B, that communication is somewhat completely independent from the communication that is happening from C to D, right? So in that way, now every device, we are correctly delivering to the port that corresponds to the actual destination only, and others are not given access to the data anyways. So with the hub or as well as with the classic Ethernet, every computer that is attached can see the traffic sent between all of the other computers. So that is, if a device is capable of seeing all other communication, we can say that the device is in promiscuous mode. So by default, in hub-based as well as in classic Ethernet, the devices are in promiscuous mode, and that is not the case with the switch-based Ethernet. So the spies and busybodies love this feature, of course, but with the switch, the traffic is forwarded only to the correct port, right, where it is destined. So this restriction provides a better isolation so that the traffic will not easily escape and fall into wrong hands. So that kind of a protection we are getting additionally, other than the other benefits, right? So however, if you want further more protection, you should go for the encryption technique, right? You can make your traffic encrypted, and you can achieve more security, of course. But anyway, to some extent, you are getting security benefits with the switched Ethernet even. So that's all, the hub-based Ethernet and its variation switched Ethernet. It's switched Ethernet, something dominating in our current world scenario, and it undergone many variations like fast Ethernet, gigabit Ethernet, 10 gigabit Ethernet, like that. So we will see a quick review of those things in our subsequent lectures. Thank you.